All right, welcome. This is our intro to rational exponents. So what I want you to do is I want you to start by pausing the video and trying these 10 on your own without a calculator, okay? All right, let's see how you did. So if you used a calculator to check anything, like that's absolutely fine because you're just checking to see if you did it right. But please keep in mind, this is all no calculator material. This is all stuff that you would need to do without a calculator. So 2 cubed is 3 cubed, I can read, is 3 times 3 times 3, which is 27. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. Negative 5 cubed. Don't have this confused with negative 5 cubed. This is negative 5 cubed. 5 times 5 times 5 is 125, and then take the opposite of that, that's negative 125. 4 cubed, 4 times 4 times 4, 4 16, 64. 7 to the negative second. So we have a negative exponent here. As a reminder, we cannot have negative exponents in our answers. There is a property that says that if you have a to the negative m power, that is equivalent to 1 over a to the positive m power. So this is equivalent to 1 over 7 squared, which is 1/49th. Over here, 2 to the 5th power, we already did 2 to the 4th power is 16, so multiply that by 2 one more time, and you get 32. 2 to the 3rd power is 8. We have the cube root of 5 to the 3rd power. So remember, a square cancels out a square root, and a cube root cancel each other out. So we just get 5. The cube root of 8, what number do you multiply by itself 3 times to get 8? That's 2. And then the cube root of negative 1. What number do you multiply by itself 3 times to get negative 1? That's negative 1. Okay, so next here we have this entire slide that I want you to once again pause the video and try by yourself, and then we'll come back and look at it together. All right, so here I want you to see, what do you notice about this table, right? So we have integer exponents, 2 to the 3rd power is 8. Then we have the cube root of 8 is 2. And then 8 to the 1/3 power is 2. Now, if you needed to use a calculator to get these ones on the right because you just didn't know what they are, that's absolutely fine. But we're trying to look to see how you can get it, or like similarities in the table, right? So if you were like, oh, I didn't know that, then pause the video, get the other 4 that you weren't able to get using a calculator so that you can see some connections here, and maybe that'll help. Okay, so 6 squared is 36. Square root of 36 is 6. And 36 to the 1/2 power is 6. 3 to the 4th power is 81. The 4th root of 81 is 3. And 81 to the 1/4 power is 3. 1 to the 5th power is 1. The 5th root of 1 is 1. And 1 to the 1/5 power is 1. Negative 3 cubed, once again, that's negative 3 cubed. Negative 3 times negative 3 times negative 3 is negative 27. The cube root of negative 27, what do you multiply by itself 3 times to get negative 27? Negative 3. And the same question for the last one. All right, so notice how I phrase it, the same question. These are the same thing, right? And so are in each of those columns, okay? So here it says, study the table above, what do you notice, what do you wonder? What conclusion can you draw about the rational exponents? And what do you think an exponent of m to the n indicates? So for example, what do we think that if we had 8 to the 2/3 instead of 1/3, what that means? All right, so just before we get started really quickly, and we'll answer those questions as we go here. What I want you to notice, because it's part of our next slide here, is that the cube root is the same thing as the 1/3 power. Square root is the same thing as the 1/2 power. 4th root is the same thing as the 1/4 power. 5th root is the same thing as the 1/5 power. And this is another cube root, is the same thing as the 1/3 power. So here, to summarize this, for any real number b and any positive integer n, we know that b to the 1/nth is the same thing as the nth root of b. So if you don't know what 8 to the 1/3 is, you can rewrite it as the cube root of 8 and say, oh, that's 2. Okay, so coming back to this one right here, like let's look at this one right here. We have 8 to the 2/3 power. We can, if I don't know what 8 to the 2/3 power is, I can rewrite this as the cube root of 8 squared. All right, the cube root of 8 is 2. 2 squared is 4. All right, so you can evaluate that. All right, that's pretty nice, huh? Okay, so let's go ahead and try these also, just like in case you're a person who needs something, a little extra help here. I teach this to my integrated kids, is that if you look at this rational exponent, remember rational exponent, we're just talking about exponents that are fractions, that's what they look like, right? If you look at it as a flower, right, and you're like, what are you talking about, lady? So here's that bar, but that's also the ground. Here are where the plant's roots are, the flower's roots, right? So this is root, and this is power. What kind of power? Flower power, all right? So your power is up top, and your root's on the bottom. But if you look at it as the 1/3, and that's the root on the bottom and the squares on the top, that also makes plenty of sense. All right, so this section right here, rewrite each expression using radical notation. So all that we're doing is rewriting. We're not evaluating, but all of the problems that we're giving you here, we can't evaluate anyways. All right, so here we have 6 to the 1/5 power, so we can rewrite that as the 5th root of 6. Next one, 3 to the 2/3 power, so we can do the cube root of 3, and then squared. Also, please keep in mind, this can be the cube root of 3 squared. It's the same thing. Those are the same exact thing. Okay, it doesn't matter which one you do. Usually, mathematically, this one's easier to solve because making the numbers smaller, cube rooting something, then squaring it is either easier mathematically than squaring something, making it bigger, and cube rooting it. But they're equivalent. It doesn't matter which one you write. So just know that they're equivalent. So if you see them, you know that it's both. Okay, this next one right here, there's a difference between 5x to the 7/4 and 5 times x to the 7/4. This is 5x to the 7/4, and we would 4th root 5x. That's not what this is. This is 5 times x to the 7/4, right? So we are going to keep the 5 in front of the radical, and then we have the 4th root of x to the 7th. Or it can be written like this with the 7th out here, just so we're aware. This one right here, oh, I didn't realize that was the next example. So the next example, yes, we have the 4th root of 5x to the, and then the 7th can be underneath there with it, or it can be on the whole entire thing outside, but the 5x is underneath the radical for that one. Okay? All right, so next one, notice they write it how I write it right here, right, in these problems, so it's good that you saw both, yeah, okay? Rewrite the expression using exponential notation. So this is going to be 4 to the 8, that's the power, 5ths, that's your new root. This is 7 squared, and then you're going to cube root it, so 1/3 power. 5 to the 4th, and then the root is 9. And then we have a 6 in front, x to the 4th, and then the 9th root. Right, and it's the 6x is not in parentheses because it's the 6 is not underneath the radical. All right, these next parts right here, this is evaluating. So we're going to do the exact same thing we were doing here, but we are going to give an answer because these ones will know. Right, so like this one, we don't know the cube root of 3. We don't know the 5th root of 6 because those are all decimal answers, right? That won't happen. All right, so this one says 16 to the 3/2 power. So 16 to the 3/2 power, like maybe blank stares I'll get. So if it's in radical form and you don't know the answer, convert to a root, okay? Or sorry, I said that wrong. If it is in rational exponent form, convert to radical notation or a root, okay? All right, so we're gonna say 16 cubed and then square root of that. So the square root of 16 to the 3rd power, or the square root of 16 to the 3rd power. Either one is fine. It doesn't matter which order you do it in, right? But if I had it this way, we'll go back to, no, it won't. If I did 16 to the third power square root, you might be saying like, I don't know what 16's cubed is. I need a calculator. And then to square root that number, like, oh my goodness. So I would always do the root first. So do the square root of 16 and then cube that. Square root of 16 is 4. 4 cubed is 64. Boom, right? This is great, love it. All right, next one right here, we have the cube root of 64. And then that's the negative second power. All right, so I'm gonna do the cube root of 64 first. What number do you multiply by itself 3 times to get 64, and that's 4. Hopefully you'll have these memorized. I'm just saying where I'm getting my answer from, so you're not like, how'd you know that? And that's to the negative second power. As a reminder, can't have negative exponents, so we write it as 1 over 4 squared, which is 1/16. This one right here, we have the 5th root of 32 to the negative second power. The 5th root of 32 is 2, because 2 times itself 5 times gives you 32. That's the negative second power, which is equivalent to 1 over 4. Last one, we have negative 27 to the 1/3 power, not to be confused with 27 to the negative 1/3 power. So this is negative 27, the cube root of that, and then that's to the first power, right? Or just the cube root of negative 27, let's be serious, which is negative 3. Okay? All right, lastly, we have solve each equation. So if you look, these have rational exponents, and we want to get rid of that rational exponent. So we could rewrite these as radicals. Don't suggest that. Instead, what we're going to do is we're going to get rid of the rational exponent, okay? So first off, it has to be isolated, so it has to be by itself like this, like the 1/3 on that quantity inside that parentheses. If there was like a 6 in front here, the first thing we would have to do is divide both sides by 6, but that's not the case in any of these problems, okay? Or if there was like a +5 right here, the first thing we would have to do is subtract 5 from both sides, okay? All right, so I need to get rid of that 1/3 power. I need it to be a first power. So I'm going to say, all right, well, I'm going to bring this whole side of the equation to something so that 1/3 turns into a 1. What's going to make that happen? The third power, because 1/3 times 3 is 1, right? And it's a power to a power, so we multiply our exponents. What we do to one side, we have to do to the other, so I have to cube this side also. This 1/3 cancels out with this cube. We're left with x squared minus 6x is equal to 8. This is a quadratic with an x squared and an x, so the first thing I'm going to do is try to factor it. It needs to be equal to 0 in order to do that. There is no GCF, but I don't know two numbers that multiply to give me -8 and add to give me -6. I was going to say do on accident because I was thinking of -4 and 2, but sorry, -4 and -2, but that doesn't, if this was it, I'd be fine, but it's not. So I need to either complete the square or use the quadratic formula. I'm going to complete the square because the numbers are pretty small here and it already has a lead coefficient of 1. So I'm going to add 8 to both sides. I'm going to take half of b, which is -3, and square it. So I'm going to add 9 to both sides. I'm going to factor the left-hand side, which is x minus 3 quantity squared. I'm going to add those two numbers, which is 17. And now I'm going to square root to solve. So square root plus or minus. I have x minus 3 is equal to plus or minus root 17. And then I'm going to add 3 to both sides. X equals 3 plus or minus root 17. And there's my answer. Oops. Now, if you have an even root, you should be checking your answers because you could get extraneous solutions. So we should check your answers no matter what. But we just want to make sure that we're not getting extraneous solutions. But if you look, this is a cube root, which we can take cube root of positive numbers and negative numbers. So its domain is all real numbers, so we don't have to check the solution on that one. This one is also a cube root. This one is a fifth root. So on all three of these, we don't have to check the solutions. Okay, So let's move on to the next one, speaking of the next problem here. So I need to get rid of a 2/3 power. So I'm going to bring this to the 3/2 power because that's 6 over 6, which is 1. So now it's the first power. And what I do to one side, I have to do the other. So I have x plus 8 is equal to. And now I'm going to rewrite this in radical form because I don't know what 9 to the 3/2 power is. So I'm going to rewrite it in radical form. So I have square root of 9, right? And remember, whenever you are solving by square rooting, you have to account for both the positive and negative solution. So plus or minus the square root of 9 cubed. All right, so I have x plus 8 is equal to plus or minus the square root of 9 is 3 cubed. So I have x plus 8 is equal to plus or minus 27. So I have x equals negative 8 plus or minus 27, and then I can get my two solutions for that because I can simplify that. So we have negative 8 plus 27, which is 19, and negative 8 minus 27, which is negative 35. Okay, or from here, you could have done x plus 8 equals 27, x plus 8 equals negative 27 and solved each. We know that, but I tend to do it the way I did it. Okay? All right, last one here. I have to get rid of that 2/5 power so I can get x minus 4 by itself. So power to a power, and I want it to be a 1, so I'm going to do 5 halves. 5 halves. And I have x minus 4 is equal to, this is 10 over 10, so that's 1, they cancel. And then same idea here, I'm doing square root of 4, right? So since it's square root, I have to do plus or minus to the 5th power. X minus 4 is equal to plus or minus 2 to the 5th power. X minus 4 is equal to plus or minus 32. X equals 4 plus or minus 32. And then once again, I can simplify that because I can add and subtract 32 from something. 4 plus 32 is 36. And 4 minus 32, I don't like the way that 36 looks. OCD, sorry. And then 4 minus 32 is negative 28. Okay. All right, that's it today for the intro to solving rational exponents. You can go ahead and work on the homework.